All right, welcome to our free GMAT prep hour for May 2024. I'm Dmitry. Today's focus is going to be quant heavy with a bit of DI. Basically, we're going to talk about charts to solve every kind of problem, or at least a lot of kinds of problems. And I felt a little lazy today because I felt maybe I should have drawn really pretty slides that really showed those charts really nicely worked out in tables and things. And then I thought, well, maybe I'm not being lazy because who would ever make that on the GMAT anyway, right? We don't have time to get out a straight edge and make everything beautiful. So I want to show you that charts can be constructed very quickly because a lot of people think they don't have time for that kind of thing. And I have just grown increasingly chart happy over the years. It's one of the tools that, teachers push that I think teachers actually use. Some of the stuff we do, and it's not that it's not good to use, but some of the tools that we give are more, hey, if you don't feel comfortable with this topic, here's something that will help you feel comfortable, or here's something that if you're struggling might get you to another level. But then there are tools that I think, regardless of your level, whether you're doing so-so, whether you're doing great, just make you more accurate, just make you more consistent and organized. And I think a lot of people misunderstand where success on this test comes from. They think you need to know more content, um, harder topics, trickier little rules. There's some of that for sure. But I think at any given time, where are we going to get the most improvement? It's from using what we already know, what we already have in a more efficient and accurate way so that we actually get questions right. And I think it's so common that we look back on tests and we go, oh, why did I miss that one? Why did I miss that one? Sometimes the questions I miss on a test are the hardest ones. And sometimes they're just random ones that I just did wrong. When I most recently took the GMAT focus, I missed the very first question. And I don't think it was a terribly hard question. I think it seemed straightforward. It made sense. I kind of double checked my work and thought about it, and it still seemed like I had the right answer. But something in my approach, something in my setup was clearly wrong. Um, and it didn't knock my score down too far, but it certainly made it take a little longer for the score to move the way I wanted it to move. And so we're trying to avoid those situations as much as we can. We may never avoid them 100%. But I think a lot of the things I want to share today are about how we organize so we catch more of this. So with that in mind, I'm going to kind of do this in a bit of a spoilery fashion, which is I want to show you um, some of the charts we'll use in the solutions. I'm going to give away some of the solutions in advance without giving you the answers, and just talk about how we're going to build things. And so free to stop me and slow me down on any of this stuff. But a few of the common charts that I want to get you comfortable using, and nothing too crazy, I don't think. So one of the most common types is one of the most simple types. And I think you might find yourself doing some variation of this chart several times in even one quant section, and certainly across quant and DI, very likely several times. And the idea would be some kind of before-after chart. It might not literally be a change. It might just be 2 different years and what happened in those years. But the idea of the chart is going to be something like, for instance, maybe I have two people, A and B, and how much money they had before and after they they traded some money, or one paid the other or something like that. So maybe that like person A has $8 and person B has twice as much, but then person B gives person A $10, right? So now A has 10 more and B has 10 less. And then they may give you some other relationship where you then know, okay, for instance, if they tell you now the ratio of their amounts they have now, you can figure out what that amount was, like how much person A had, how much person B had. A related approach that we'll see is the age problem, where it's the same kind of thing, right? You have something like, okay, here's Joe and here's Kathy or something like that. And then you have some time frame. So maybe they'll talk about 5 years ago and they'll talk about now. With these, typically what I do is I make very clear that what my variables mean, right? So if I say J and K, that might seem clear enough, but I'd want to be clear. Am I saying J and K stand for their ages now? That's the most typical thing I do. Then I'd say, hey, right now Joe is J years old and Kathy's K years old. Okay, fine, fair enough. Then what they'll often say is like something like 5 years ago, Joe was 3 times as old as Kathy. Don't try to write that equation yet. Instead, do the simple adjustments, the 5 years back. Then you can say, okay, 5 years ago, what did we say? Joe was 3 times Kathy's age. Even better, what we'll often do is if we know which one we're solving for, we'll do everything in terms of that. So maybe they give you something like, now here I wouldn't be able to do it because I didn't give you a relationship between the ages initially. But let's say they tell you something like we had in the first one with the money, where if I said, okay, uh, Joe is twice Kathy's age. Well, then I could say something like, or Kathy is twice Joe's age. Let's say that. I'll just right now I could do something like this. Okay, if Kathy is twice Joe's age, then I could say that 2 years ago she was like this. Then when I want to say something like, okay, 5 years ago, one was 3 times the other, I could say, okay, Kathy must be the older one then, right? So I'd say 2j minus 5. And we could actually solve, right? So this is a kind of setup we often use, a before, after, or an age problem. In the end, they might ask you about a third time frame. They might say, how old will Joe be 4 years from now? Um, and then we can do that separately. We don't necessarily need a chart for that if they're not saying anything else about that time frame. But just getting those time frames straight is very valuable. And so we can go from there and find an actual age, right? In this case, we'd go in there and okay, 2j minus 5 equals 3j minus 15. And so we'd get j equals 10, and we could verify that. Okay, if this one's 10 and that one's 20. Then 15 years ago, this one would be, sorry, 5 years ago, this would be 5, and this would be 15. Yep, that's 3 times as old. Everything worked. We don't even necessarily have to verify if we're confident that our work's okay. But the idea is that we keep that stuff organized so we're not trying to hold it in one place. Because what tends to happen is that we can make this equation. Like most of my students who feel okay about algebra will say, I can make this equation. But there's a difference between can and do. And often people will just set the equation up incorrectly. They'll make some mistake, they'll drop some piece, and they won't ever realize they did it. Okay, so those are two kinds of problems we'll see. You can also see this with something like a ratio, right? We'll talk about a ratio problem. In that case, maybe we get everything in terms of the same variable, but we kind of have that already here. In a sense, these already are ratio problems because I'm saying that one thing is twice another, and then there's some adjustment, and it's no longer twice as much. It's some other amount. Okay. Another kind. Have you seen the overlapping sets problems, right? The kind where there's like two binary choices, two groups. Okay, yeah, yeah. Oh yes, right. Those are a familiar friend, right? And so the idea with this is they can occur different ways. Sometimes there's two clear um binary choices that are defined, right? For instance, like everyone orders either the meat dish or the veggie dish. It's one or the other. Um, and everyone gets a alcoholic drink or a non-alcoholic drink. And then you could look at what they order, right? So here they've defined the binaries. They don't say just meat and not meat. They say meat and veggie, alcoholic and non. And I can, depending on what they give me, maybe if they're giving percents, I just call the total 100% or 100 people. If they're giving me actually numbers, right? Maybe they say like, okay, 24 people order alcohol with veggies or whatever else. Maybe I have to find the total and I'm adding up actual numbers. But one way or the other, I can represent all the pieces this way. Other times, um, they'll give me two choices that sound like they could be binary together, right? Like they'll say, um, for instance, everyone has a full-time job or a part-time job, but it might turn out to be that it's about, hey, either you have a full-time job or not. And then separately, side hustles and all, you also have a part-time job or not. And then it might look something like this. And the same thing could be something like if you two languages that you might speak. right? Those aren't usually binary unless we're saying everyone who speaks one doesn't speak the other. Like if you speak Mandarin, you may or may not also speak English, right? Um, but here it could be like this. Hey, this box would be people who have both a full-time job and a part-time job. This would be people with no job. This would be people with just a part-time job, and this would be people with just a full-time job, right? That's all lazies, right? Um, so you could kind of organize that way. Um, what if you see three groups? Like you see something like people could order um, a meat dish, a veggie dish, or a dessert, or any combo of those. How do you represent that? There, when we have a a matrix like this, that works nicely for two. It doesn't work nicely for three because we're ordering third axis speed coming toward me, right? 3D off the screen. So for those, we often use a Venn diagram. I'm not a big booster of Venn diagrams for the double sets because they often are just too complicated to work well with this. But the triple sets, often this is the complication. And so we can represent it something like this. So here, let's say here's all the people who ordered meat, here's all the people who ordered veggies, and here's all the people who ordered dessert, right? Um, and then you can see all the combos, right? So maybe let's say maybe there's three people who ordered all three things, and there's two people who ordered just dessert and veggies, and one person who ordered just meat and dessert and no veggies, and this kind of thing. And then depending on the totals, you could work your way out, right? So if I know that a total of uh, 15 people ordered the veggie dish, I could say, well, let's see, there's three here and two here. That's 10 left, so it could be like this, but then this number would have to be 0. Or if I can find out what this group is, maybe there's two people who ordered both meat and veggies. Now I'd say, okay, 3, 5, 7. There's 8 people who ordered veggie only, right? So I can work out like that. I would just have to think about which boxes I know, and is there overlap between them? For instance, they might tell you 15 people ordered veggies, and you might think that you can put 15 in the outer ring, but 15 has to include all the rings separately. Right. Additionally, there might be a value outside the rings. Maybe it turns out that there are 5 people who didn't order anything, and so we have to think about if they give us a group total, does it include that? And then finally, another favorite is rate and work. Uh, the basic formula here is just rate times time equals work or distance. And then the most common situation, not the only one, but the most common situation is one where I'm adding rates, right? So if one person goes, and basically what's important to remember about rates and work is that anytime two cars, trains, people, robots, printers, hoses, whatever it is, are working toward achieving the same combined goal or effect, then you're adding the rates. That could be combined goal in the sense of we're both working to finish a job. It could be we're both trying to close the distance between us or driving toward each other. It could be, like I said, two hoses like filling a pool. Um, Anything, it doesn't have to be intentional. Like you and I might be driving toward each other, but not know each other. Like we're just crossing each other on the freeway, right? But it could still be like, hey, if you're driving south and I'm driving north, how long is it before we pass each other, even if we're not, working together in any way? If we're working toward the same goal, but we're competing against each other, then you subtract rates, right? So let's say um, that you're going at 5 miles an hour and I'm going at 4 miles an hour, then you're going faster than I am. So depending on the scenario, then we do A minus B, right? In that scenario, we would do, okay, what's happening at 1 mile an hour? You'd have to define that. It's how fast you're outpacing me. If you're in the lead, that's how fast you're getting away from me, right? Maybe you're 10 miles ahead of me, and every hour you get further, 11 miles ahead, 12 miles ahead, etc. Or if you're coming from behind me, it's how fast you're catching up. And so a common scenario might be, if I am 10 miles ahead of you, how long does it take you to catch up to me? Well, you're going a mile an hour faster, so in 10 hours, right, you could do something like this. Um, but again, the more common scenario is that we add the rates. You're coming toward me at 5, I'm coming toward you at 4. Together, we're going 9 miles an hour, and we divide into the work or the distance to see how long it takes us. Is that? Okay. So thoughts, questions, gripes about any of this stuff? And I'll set you loose on some problems. Okay. Let's try a few things. So for each one, what I'll have you do is just pull in your answer when you have it. Um, if you're watching the video and we stop you too soon, that pause it for a second and finish up. But target time for each of these will be around 2 minutes. Okay, so give this a shot and let me know when you got it. All right. So let's see how we're doing with this. Let's see if we can set it up with a chart, right? So we can do this one because it's got an initial set of values and a change set of values. We can do a before after chart. You might literally label it before and after, or you might just have the idea to yourself on your paper that the two columns represent the first case and the second. So you don't have to write before after. But you would want to track what she has, right? So they're talking about checking. So checking, we know she starts with 10,000. What does she end with? Still 10. And so you might just write down, yeah, just 10, forget the thousands, right? Just say she has 10. It's not going to change anything. It would, of course, change if I thought it was $10 and then they added 600 and I said 610. But as long as I keep the scale, 80,000, 10,000, 70,000 is just 80 and 10 and 70, I can get rid of the thousands. It's like simplifying a fraction. And so I know that her total is 80. Now I don't know how many accounts she has, but that's kind of window dressing, right? What I know is that the rest is going to be 70, yeah? So I might make my chart something like this. So far, so good. So what happens in the after column? She's going to take out half the money in her investment accounts. So that's the remainder, right? I could have written investment in my chart, but I didn't. I just put rest, right? But okay, she's going to take out half. So I can total that. Cool. And they want to know what percent of our total account holdings are in checking. So at this point, we're really just saying 10 over 45 is what percent, right? You could call this a proportion, is what over 100. You could just divide 10 by 45, right? Simplify. What do I know about this before I, assuming I don't have my calculator, assuming this is in the quant section, right, which it looks like, what do I know about this answer? If I were to double this, I could say double of 10 over 45 is 20 over 90. So it's got to be over 20% because 20 over 90 will be more of 100. So it's got to be over 20%, and I can get rid of these. but it doesn't look like it's going to get to 25%, which would be 25 over 100. If I'm not sure about that, I could simplify this down. It's 2/9. If this is something you can memorize, a ninth is 0.1111111, which you can know because 9/9 is 0.9999, which, believe it or not, is the same as 1, right? They're literally the identical number. That's kind of weird, but true. So we can know that a ninth is 0.1111. So this is going to be 22.22222%. So the answer is D. Another way you could get there would be to say, hey, look, this is 10 over 45. So that's 1 over 4.5. And you can think about it as a benchmark. 1 over 4.5 will be somewhere in between 1 over 4 and 1 over 5. And those kind of benchmarks can really make you feel more confident in your work, which is another thing I'm trying to get. I'm trying to feel like not only do I think I have the answer, but I'm pretty confident that I'm right, that I really know that I have it, right? So if I know that I'm assuming my work is correct, that I'm between here and here, then the answer has to be D, and I cannot choose E. Okay, is that all right? So a chart is not, it's not going to do all the work for us. It's not going to prevent any mistakes, but it's going to keep us a little bit more together a lot of the time. Okay. Let me do a different kind of chart problem, but the same thing that has a change with the before and after. So try this one. Okay, so this one's a little sneakier, partly because they don't give you nice concrete values. They tell you the ratio of the scores, or if one is a fraction of the other, and they give you a change in the scores, but they don't really tell you the actual values. And that's what you're, meant to figure out. So we notice though that we can use a lot of the same structure. We can still put the two people in there. Um, we can still have a before or after, or if you like, we can have round one, round two, and total, right? The GMAT might even write this slightly more carefully. This is one of ours, but they might even say something really clear that, your total score will be the sum of your scores from the two rounds or something like that. It's not a weighted average, or you don't start with any points or anything like that, right? Just to be super, super clear. But I think there's relatively clear enough that like she gets some points in the first round, they get some points in the second round, and then there's going to be a ratio. So we can think of this as a ratio problem, and often we'll write that as an unknown multiplier problem. We'll say, okay, Lori has 3x and Ivy has 4x. We could, if we want to be less abstract, x is kind of an abstract number. You could say Lori has L points and Ivy has, let's see, so if Lori has 3/4 of Ivy, then you could say 4/3 of Lori will be Ivy. So I could do that. But then I notice I have to use fractions, right? I have to say one thing is 3/4 or 4/3 of the other. Whereas if I simply say, hey, the ratio is 3 to 4, then I could say x equals some multiplier, right? And the idea on a ratio problem is that I don't know how many points Lori and Ivy have, but Lori has a multiple of 3 points and Ivy has a multiple of 4 points. And assuming that their points are numbers are integers, which seems safe to assume. You know, again, the GMAT might be careful about that. Sometimes they do it by like saying like they have marbles or they have coins or something like that, right? Then I could say, oh, then Lori's points must be a multiple of 3, and Ivy's must be a corresponding multiple of 4. So either they have 3 and 4, or 6 and 8, or 9 and 12, or 12 and 16, or 15 and 18. 15 and 20, etc. Right? Um, and so for that reason, in fact, we could get rid of answer race B because that's not a multiple of 3, right? She's not going to have 5 points because then what's 5 3/4 of some funky number? It's not an integer. Okay, so then in the second round, they tell us what everyone gets. Lori gets 20 points. Ivy gets 20 points. Okay, so we can have the running total. And again, the idea of the chart is it's not very revolutionary, and that's the whole point. Anyone can understand this chart if they look at it, right? And that way we can go in and find the pieces that we need a little more easily, and we're not trying to hold it all in our head. And so I think a common misconception of the chart is that we somehow couldn't understand this without the chart, or there's no way to do the algebra. This is only for people who can't do that. No, on the contrary, right? Most of my students can do this algebra, but it is easier and simpler a lot of times to not set it up in terms of a bunch of equations and to not try to hold all the pieces in your head at one time, right? So since you don't have a friend to talk to, you don't have a calculator most of the time, I think using that one tool you have, your pen and paper, is really valuable. So now I can just say, okay, the ratio of their total scores is 8 to 9. Well, the ratio is just a proportion that we can set up. So this I do outside the chart. I'd say something is in the proportion of 8 to 9. What is it? Oh, it's the ratio of their 2 scores. Okay, so now it's just a little bit of cross multiplying. Right? Should have something like this. Uh, uh, and then 20 equals 5x. X is going to be 4. And then what is it that I want? Sometimes what I'll do is I'll mark what I want in the chart. It's another valuable thing you can do with the chart. I want Lori's score in the first round. So it's not 4, right? Which thankfully is not an answer. It's 3 times X, which is 12. Okay, so that's use of an unknown multiplier for a ratio, but it's using it in a chart to organize your pieces and mark what you want. Okay. Alternative strategy, by the way, you could use here, where then you might be a little less likely to use a chart, but you could also just test the values. This works nicest when we can start with, say, B or D. Here, since if B is not a value I want, I might actually start with D and just test. Okay, well, let's see. If Lori had 9, then that's 3/4. Okay, so Ivy would have 12. If you add 20, that's 29 and 32. Is that 8/9? But then you have to check, is that 8/9? And then do I want to go up or down? And that's a working backwards strategy that is worth practicing, worth getting good at. So I would play with that on this one and see what you make of it. But I think this is one where you can work pretty well forwards too. Okay, thoughts there before we move on? Okay. Then we'll get to one of these age problems. And so once again, it'll be a chart, and there's a before and after, although here we have sort of time frames, so it's slightly different. It's not just a random before and after. Generally, we're going to want to get these all in terms of our needed variable as soon as we can. A few quirks here, right? So let's try one like this. And there's your poll. All right, let's see how this is going. So we can have our usual before after kind of chart on this one. Um, but in this case, the after is a very specific point. It's not just like the next day, it's some number of years later. So what I would probably write is now and plus X years in the chart. And so I have two people, Toshi and Kosuke. Now, sometimes, and we teach this a lot in our course, when you see an in terms of in the answers, like the 2x, 3x in terms of that variable, you might just make up an x and see what happens. The problem here is that there's another unknown we're dealing with, which is, or a pair of unknowns, but they're connected, which is how old they are now. And if I try to make that up too, it won't work, right? Because if I just say, I don't know, let's see, he's 4 times as old. So let's say that he's 8 and he's 2. And let's say that X is 4. So in 4 years, he's 12 and he's 6. He'll be 3 times as old. Oh, he isn't 3 times as old. He's twice as old. Oh no, that didn't work. So I have to be careful. This isn't one where I could just make up whatever numbers I want. I could make up X, but then I'd have to figure out what numbers would work with that. And that might not be easy to do. So I'd probably rather just use a variable. And here they've made it kind of straightforward in that K is the person we're looking for. And they've said Toshi is 4 times as old as K, so I can just say K and 4K. And then what I always do, and these are sort of standard things I'll do for an age problem. Uh, and is anything where they have this kind of setup where there's some relationship between ages, and then some amount of time passes, or we'll go back some amount of time, and how old were they? There, what's the relationship between their ages then? So I would set up with columns for time frames, kind of thinking of time as linear, right? We could put the columns along the side, but time moving forward or back. Um, Express in terms of one variable if you can. Usually the target person's age now, but that can vary. If it's something like when they met, Kosuke was, this much older or younger, right? Then you might start with the ages when they met, right? Or the beginning of the story, right? But usually it's going to be now. Um, and then do the time adjustments. And you don't have to use any extra knowledge, right? The simple time adjustment. So what I mean by that is, let's say we knew what X was. It was 2 years, let's say. Then we could just say in 2 years, they'll each be 2 years older. If it's 10 years, okay, in 10 years, they'll be 10 years older. But that's an easy adjustment to make. I can always add 2 or 10 or even X or something. Whereas sometimes there'll be something like 5 years from now, Catherine will be 1/3 as old as 5 years younger than that. Save that, right? So just do the automatic adjustment. So it's almost like what Excel would do for you. In X years, Toshi will be 4K plus X. And in X years, Kosuke will be K plus X. Now, set up, often there'll be just one equation left. Set up an equation using the remaining info, whatever you haven't used. And so in this case, I haven't used the 3 years old as old part. Sometimes I'll even start in English first. I'll say something like, oh, future Toshi will be 3 times as old as future Kosuke, which is just a way of keeping myself a little more organized. And then I just fill those in. Future Toshi will be 4K plus X, and future Kosuke will be K plus X. And now I can just kind of work that out. Okay, 4K plus X equals 3K plus 3X. K equals 2X. And then, oh, what do I want? That's it. That was my answer. Again, I should have probably marked this in advance. That's what I want, just to make sure I get it. And there's my answer. That okay? So this is a good process to more or less memorize, just because there's a fair chance. I can't guarantee what you'll see, and especially now that the GMAT has gotten shorter, like the sections have gotten shorter, there's a bit more chance in what you'll see. Are you likely to see a combinatorics problem? Well, maybe one. Could you see two? Well, two is a lot. 10% of the questions can be combinatorics, or age problems, or rate problems, or whatever else. So often you'll see one of this, one of that. Sometimes they fit more topics in by combining them. They mix in, rates and work with something about triangles. Yes, occasionally you'll still see a triangle or something geometric. They'll mix in probability with ratio or something like that. But there's a bit of chance in what you see. But it's good to, know a lot of the common cases. So you're, decent chance that when you see something new, you go, oh, I've seen something a lot like this before. You don't want that many surprises. Usually on a given test, there'll be a few things that drive me crazy, or I don't feel like I have a ready set approach for, but I'll have time to do them because on some of the other questions, I've looked at that and said, oh, what are these? I know how to do this. Oh yeah, I do this all the time. Oh, this is a very familiar setup. Okay, I have a thing that I can do kind of automatically. I feel like I'm on my home base, so to speak, right? My own territory. Okay. Let's get to the overlapping set side of things. Now, I'm adding a bit of data sufficiency to this. So if anyone's watching this and doesn't yet know how to do data sufficiency, you could skip it, or you could look up quickly how to do data sufficiency. I'm not going to teach that right now. But let's look at how to approach one of these charts when you have two wrinkles. One, now it's a double set, right? Do you speak Spanish or not? Do you speak French or not? And then two, you have two statements, and you might have to think about, do I want to make a chart for statement one and then make another chart for statement two? Do I want to kind of try to sequester my information in a corner of the chart, or try to keep it in my head? I think it's usually faster just to make two charts, or maybe not faster, just more accurate to make two charts. But again, it depends on your own comfort level with this stuff. Some people might not feel it comfortable or convenient to make two charts. You could try to make one and just constrain the information. But try this out, and then we'll talk about it. All right, so let's see what we can do with this one. I gave a little spoiler at the beginning, just to, make sure to set you up. Um, that when you have something like this, when you have people who are maybe studying French and people maybe studying Spanish, but it doesn't say, that they have to just study one. In fact, it tells you they might study both. Then you don't want to put French and Spanish on one line. You want something that looks like French, no French, total. And again, I'm just going to do this quick and ugly on the fly. It does not need to be beautiful. Spanish, no Spanish, total. And so one quick way to do that is instead of saying even just like no Spanish or no French, just crossing out, right? So then we have something like this. And again, these double set matrices will then represent all the possibilities. We call it a matrix in class. It's not a matrix in the sense of like matrix algebra. It's just a tic-tac-toe board that holds all your information that they add up to two totals. And so before I get to either statement, I can fill in the knowns. I know 120 students are there. 75 are speaking Spanish. When they don't say otherwise, that means everybody who speaks Spanish. We don't want to make an assumption that they study only Spanish, right? So there's 75 kids in total who speak Spanish. And they want to know how many kids are studying French. So that would be how many kids are studying French overall. Okay. So we can fill in an inference, right? If there's 75 kids who aren't studying Spanish, then all the rest are not studying Spanish. Sometimes people feel that's an assumption. It usually has to do with how they say it. So here they say of the 120, 75 are studying Spanish. That means that's it. If I say like my town has 2 million people and I know 10 people who are studying for the bar, that doesn't mean they're the only people who are studying for the bar. Then I don't know what the number is, right? So they'll usually be pretty careful in their phrasing, right? So if they say something like all of the boys are studying Spanish, you're like, okay, so but what about everyone else? We don't know, so we'd have to be careful. We don't know our totals yet. Okay. So this is what I have from the beginning. Of course, I can't solve with just that, or it wouldn't be a data sufficiency. I'm always wondering how much data is needed. Um, so I can go to the statements. Some people will start with statement two because it's more direct. If you do that, you can do a BD ACE thing, but I'll start with statement one just because it's there, and I will usually start with the first statement. So they give us something a little bit abstract. They say the number of students in the school who are studying both French and Spanish. So that's this box here, is equal to the number of students in the school that are studying neither French nor Spanish. So how can I represent that? If those boxes are the same, what can I do? I might just say, okay, well, when I have numbers, I'll set those equal, right? If they tell me one of them is 20, then the other is 20. But I can set that up with a variable right now because I might want to see what else I can find from this. And I think a common mistake people make on this particular question, and questions like it, is that they just look at that and say, oh, interesting, but of course it's not sufficient on its own. Well, be careful about of course. Of course tends to get us. We can fill in inferences. We don't need to do all of them to get there and actually prove that the statement is sufficient. Spoiler. One way we can look at that is the general idea on these boxes. Just like when we had 75 up here, we knew we could find the 45 here. If I have any two parts of a row or column, I can find the third, even if it's an abstraction like X. So for instance, here, if there's X people who study neither, and there's 45 total people who don't study Spanish, then I can find the number of people in this box, the French no Spanish box. How? I just subtract this from this. Like make it concrete for a second. If this number were 10, if there were 10 kids who didn't study either language, then and there are 45 total kids who didn't study Spanish, then the rest of the kids in this group at least studied French. So here I can call this 45 minus X. Okay, but if I can call that 45 minus X, wait a second, X plus 45 minus X, the X's cancel. This is 45. Huh, this is actually sufficient. Notice I won't do it twice because, I don't need to fill in the whole thing. I sometimes call that the Sudoku trap when we just start filling in everything. But notice I could also have gone this route and said, hey, if this is X, if this top left is X and the top right is 75, then this is 75 minus X. And this is 75 minus X and the thing below it's X, then this is 75. And I could have gotten from there to the 45, right? So I can fill in everything, but I don't need to fill in everything to say it's sufficient. Okay, so this actually turns out to be sufficient. So if you're familiar with the AD-BCE process on data sufficiency, I would cross off BCE, right? Sometimes when I'm in a hurry on the test, not a hurry, but since I'm used to that process, I'll just write down AD because I know that it's going to be one of those two. Either statement one works only and statement two doesn't, or they both work. But when you're getting used to it, it can help to write the whole thing down and cross this off. So then I would just go to statement two. And yeah, I'd probably recreate the chart because I've done a lot in this chart and I don't want to pretend that I, can remember which things I knew from before and which things I didn't. So I just really quickly, maybe even uglier than before, but just enough to have the data, right? Maybe I should do it with my mouse to show how ugly my handwriting would be if I were really doing this on the test. Just not really that involved. But even here where I'm like building it with Zoom tools, which is slower than using my pencil, it's not taking me very long, right? So I'd fill in what I know again, real quick, and I might kind of, if I were planning ahead, I might even have boxed these three to say, hey, I know this already, right? I know this without a statement, just to remember that that's what I know without a statement. The rest of the stuff on the left, I didn't know. So now I'll go to the second statement. 65 of the students in the school are studying Spanish, but are not studying French. Okay, Spanish, no French, that's 65. From there, I can infer that this is 10, but I want to know the total number of kids who speak French. So I want this number, and I don't know. It's more than 10, but I don't know. It could be anywhere from like maybe this number is 45 and this is 0, right? And then it's 45. Or maybe this number is 30 and this is 15 and it's 25. The point is I can't get there because I have two um, or I have an unknown below. I need two values in my column to get the third, and I don't know that middle value, right? So I have too many unknowns to get there. And so my answer here is A. Um, Real common trap to think we need more, right? And so what we got to watch for is, do I really represent everything they gave me? And a chart can be a way to keep on top of that. Okay. Then we'll move on to everyone's favorite kind of overlapping sets. Okay, probably not really. The triple set. So I gave you a hint of this with the Venn diagram. And so as I'm putting this up, I'm just gonna, because these are fairly challenging, I'm just gonna make the tool. But try this out, pull it in when you're ready, or write it down if you're watching, and then we'll discuss how to apply that tool. Okay, I'll let that run a little long, but let's see what we can do with this. So, just in terms of the setup, then the idea would be I could try to start filling in from the outside in, but I'm going to get myself in a little trouble. Um, I don't know what to do with the 100 total because I don't know where all the pieces go. And if I try to fill in the people taking English or math, I can write those here just to chart it. I know there's 45 English students and 60 math students and 57 physics students in the sample. And I know there's some overlap because those add up to more than 100, of course, right? Um, and that's what these overlaps are going to deal with. And so I can't say there's 45 here, right? Because that would mean 45 people taking either English alone or English and physics or English and math or all three. And so I won't write that there. I'll just write it on the outside for now. And so what I'll usually do is work from the inside out if I can. And if I don't have that information, like if they said at the end, how many people are taking all, then I might call this an X and solve for that, right? And then, for instance, if I know that there's 10 people taking math and physics only, then I can put that there, right? And 10 plus X gives you that amount. Or if I know there's 10 people taking at least math and physics, then I can say, hey, there's 10, and however many aren't taking all three are in this box. But in this case, I've been given those values. 15 students are taking courses in all three of the subjects. So this is 15. Now, they'll often mess with us around that realm of 2 where it gets confusing, partly just harder to word. So here it says 57 students are taking courses in at least 2 of the subjects. So I have to say, wait, at least 2 of the subjects? That means they could be taking 2 or they could be taking all 3. But I know how many people are taking all 3. So I'd say, okay, 57 minus that 15 equals 42 taking just 2, taking exactly 2. But even there, I don't know which they are, right? It could be like there's 2 people here and 20 people there and 20 people there, and I'm not going to find out. So what's a really important feature, you'll see this over and over again on GMAT questions. If there's some issue that you're not going to find out, then that issue must not matter to the solution if there's really a solution. If it's data sufficiency or one of those DI, like, supported or not supported kind of things, then that's in doubt. But if it's a regular multiple choice, problem solving question, and they don't tell you out of those people who are taking at least 2, how many are taking just English or English and math, and how many people are taking this, then it doesn't matter. So you know what I'm going to do? I'm going to divide that 42 by 3. I'm going to assume something. It's not that I think I know this. I'm just going to assume, I'm going to pretend in a sense that there's 14 people here and 14 people there and 14 people there. I could be wrong, but this is going to do a couple things for me. First, it's going to give me values to work with. Second, it's going to create a symmetry where I don't have to keep counting over and over again. So I'll show you what I mean. How many people now are just taking English? Well, I know there's 45 people taking English, and there's 14 and 14 is 28 here, plus 15 is, let's see, okay, 38, 43. So there's 43 people in these 3 sectors here, right? This, and whoops, this, and this. 43 people. So there must be only 2 people who are taking just English. But now I can reuse that same 43 because it's going to be the same for all of them because everyone has 2 sectors, right? So this adds up to 43. These 3 add up to 43. And so then how many people are taking just math? 60 minus 43 is 17. And then finally, for the third sector, physics is 57. Again, 43 people who are taking 1 or 2, 2 or 3 total classes out of that. So there's going to be 14 people who are taking physics alone. So now what I can do is I can sum these pieces, right? So I could say, hey, the 2 or more I already know is 57. That's how I made up those 14s in the first place. And then I could say, okay, the English alone is 2, and the math alone is 17, and the physics alone is 14. So if I put that together, let's see, 57 plus 2 is 59, 66, 76, 80, 90. So there's 90 people that are accounted for, but there are 100 total students. That must be our nuns. There are 10 people who are taking none of those classes. So that might be one to revisit. Certainly a challenge one. If you ever want to go back and watch this recording, you can see it fresh. But this is the kind of thing that shows up just often enough when we're doing reasonably well on quant that, it might be worth having this kind of case memorized. There's a general formula you can learn for triple sets and double sets, but it's hard to account for complexities with those formulas, subsets and overlap and things like that. So it's just a little bit unless the problem is very straightforward, it's a little tough to rely on a formula. Okay, I'll start there. I'll stop there. That is, we didn't get to rates and work today, but we have ample, we have other videos all about rates and work. So, I don't feel too guilty about that. I covered things that are maybe um, less commonly known as rate based or as chart based or things that, maybe we haven't thought about how to use the chart to simplify our life from there. Um, so stick around if you have got questions. Anyone who's watching, feel free to check out one of our classes. You can always do session one for free. See which instructor might be a fit for you, see what you make of the class. But thanks. Hope this is useful to you just in terms of thinking about how to set up charts to make things simpler, to avoid mistakes, to keep track of what it is that you have and what it is that you want. And I think I just every year that I teach this, I'm more and more sold on the idea that like we need these things to survive, unless this stuff just makes automatic sense to you. And even then, sometimes it makes sense to us, but we're still wrong. And we want to say, okay, yeah, how long would it have taken to add a chart? Not very long. Okay, so hope that's beneficial. I'll stop there. Thanks everybody for coming, and good luck with your test.